Hi friends, in this video let us solve MOSFET questions. Right, so for N-channel MOS transistor shown in the figure, the threshold voltage Vt is given by 0.8 volt. Vt is 0.8 volt. Neglect channel length modulation effects. When the drain voltage is 1.6, the drain current is 0.5 milliampere. If drain voltage is adjusted to 2 volt, changing the value of R and VDD, what is drain current, they are asking. You see here the gate and drain are connected. When gate and drain are connected, MOSFET in saturation. If you don't know this concept, kindly refer my previous video, right? There you can understand. So if gate and drain are connected, MOSFET in saturation. So we have to find a drain current in saturation, that is given by K into VGS minus VT square. Right, for first one, ID is 0.5 milliampere, K, VGS is equal to VG minus VS. We know VS is 0. Here you see source at ground potential 0 volt. G is equal to D, VG is equal to VD. So VG is equal to VD. So VGS I can write VD minus VT square. What is VD? For 0.5, VD is 1.6. So 0.5 or K into 1.6 minus 0.8 whole square. ID 2 I have to find K into when 2 volt, what is? So divide, let us assume this is equation number 1, this is equation number 2. 1 by 2 gives 0.5 divided by ID2 is equal to 0.8 square divided by 1.2 square. If you simplify, ID is equal to 1.125 milliamps. So the answer is 1.125 milliamps. And the next problem is, for the MOSFET shown in the figure, Vt is equal to 2 volt and K is equal to 1 by 2 mu C and W by L is equal to 0.1 milliampere per volt square. What is ID? So ID we have to find. Before that we have to find what is the state of the transistor, right? So here they have given Vt is equal to 2 volt. Vt is 2 volt. To find whether the transistor is in saturation or non-saturation, we need to check VDS and VGS minus VT relationship. VT they have given, VDS and VT we have to find. So what is VGS? VGS equal to VG minus VS. VG, you see this gate, so 0 because 0 potential. This is yes, source at minus 0 minus 5 is 5 volt. So VDS, right? So VD, this is VD. You see drain, it may be surely greater than 5 minus 2. Right, so VDS is greater than VGS minus VT because VD is 12 volt. You see, VDD is 12 volt. This is pmos, right? So pmos with the source, this is drain. So surely, if you want to find this one voltage across this, it will be greater than 6. So 5 minus 2. This is 6, this is VGS 5, VT2, 3 volt, 3 is greater than, 6 is greater than 3 volt. So what is ID? Transistor in saturation. So ID1 is equal to ID2 because both are flowing in the same direction. So ID1 is equal to ID2, transistor in saturation, 1 by 2 million COX W by L. VGS minus VT square. 1 by 2 million COX is 0.1 milliampere per volt square. VGS we have found 5, VT is 2. Right, so 5 minus 2. If you simplify, it is 0.9 milliampere. Thank you. Hi friends, in this video let us solve MOSFET problems. Right, so already I have put 2 videos on problems. It is the last one and the third video. Right, so yeah, depletion type N channel MOSFET is biased in its linear region for use as a voltage control resistor. Assume they are given VT, VGS, VDS, W by L ratio, COX and μN. What is the value of voltage control resistor? So the voltage control resistor RDS is given by dou ID divided by dou VDS or minus 1. So the MOSFET in linear region. In linear region, ID is given by 1 by 2 mu N COX W by L 2 VGS minus VT VDS minus VDS square. Now we have to differentiate. Dou ID by dou EGS inverse. So 1 by 2, what I get is 1 by 2 mu N COX W by L. If I differentiate with respect to VDS, what I get is 2 VGS minus VT. Here if I differentiate, it is minus 2 VDS. Right, so this 2 will be cancelled or minus 1. So RDS is equal to 1 by mu N COX W by L VGS minus VT minus VDS. So everything they are given. Mu N COX is 10 power minus 8, mu N 800. So it is 1 by 800 into 10 power minus 8 W by L 100 VGS to VT 0.5 W by L 100 to VGS minus VT. VT is, what is it in VT value? It is 0.5, right? So VGS minus 0.5, VDS is minus 5, right? So VDS is minus 5, right? So VT is given in the problem is it is minus 0.5, note down. It is minus 0.5. So what I get is, if we simplify, I get 500. That is the answer.